I'm going to talk about integrating ChatGPT into the CI/CD pipeline. However, the main goal of the integration of the ChatGPT is dealing with the old support issues. So I will deal with it. I will introduce exactly the microservices environment and the CI/CD processes, and the reason why did we integrate the ChatGPT into the CI/CD pipelines. So I'm Nir Koren. I'm leading a CI/CD team in SAP, based in Israel, and I've been dealing with DevOps for more than 15 years in all aspects, but mainly in CI/CD. And you have the details. Feel free to contact in LinkedIn and so on if you want to discuss something or get some clarifications. So the agenda, I'm going to introduce a little bit, something around 1 minute, our R&D center. I will introduce the production, the CI/CD process, the map of the CI/CD. I will make an alignment about what is microservices and what are the obstacles with microservices. And then I will move forward for supporting developer issues, because I guess most of us are DevOps that deal with supports. By the way, how many of you are DevOps engineers? Okay, something around 50%, 50, right? And then I will talk about the implementation of the ChatGPT. So about SAP, I'm pretty sure that most of you heard about SAP. This is the first biggest software company worldwide, based in Waldorf, Germany. And we are a group within SAP. We called Giga. It used to be a startup company that SAP acquired something around 7 years ago. And we are a group of 200 people that mainly deal with the identity management solution, which is 100% software as a service. We have no on-premise solutions. Everything is on the cloud. 200 employees founded in 2006. We have a lot of traffic in the cloud, 3 billion identities, 2 billion monthly logins, and so on. Mainly, we are managing identity on the cloud for many customers like NFL, Asus, and many other more. About the production, so our production within our group, I'm not talking about the entire SAP, obviously, we have 30 Kubernetes cluster with 650 nodes. We still have 6,500 virtual machines. Our main product in front of the customers, it's a single product, but it's a microservices environment. So we have something around 300 microservices, and we have 800 monthly deployment. That means that we are deploying to production 800 times per month, which is quite massive. We have 80 build agents, not including the Kubernetes and Docker and Kubernetes agents that run the builds and die after the build ends. And we have something around 150,000 monthly build and jobs that runs on top of our TeamCD and Jenkins servers, and I will talk about it in a minute. So the production data center map, it's quite straightforward. We are based in APAC, US, and Europe. We have data center based on AWS, Azure, and also we have the Alibaba cloud, since we are running also in China. And this is one of the things that we have to use. So we are, as I mentioned previously, we are 300 microservices, and we have a lot of technologies. Actually, the team decide what is the best technology for his microservice. So we have a lot of teams that most of the teams use .NET Core that runs on Docker and Kubernetes. We have also Java, Scala, Maven, C#, NPM, Python, you name it. Any service based on the team's decision. Since it's a microservices and every service exposes itself to the other services, then we don't care exactly about the technology. We do care about the standards, and I will talk about it as well in a few minutes. So if we are looking about the CI/CD process, just to keep you aligned, how many of you are dealing with CI/CD? Okay, most of you. Cool. So when we look from left to right, we're using hosted on-premise GitLab instance. And this is the source control. And we are having two CI servers. One of them is the TeamCity by JetBrains. How many of you are familiar with TeamCity? Okay. You're probably familiar with JetBrains. So JetBrains has a commercial product for CI/CD. And this is, we look at the TeamCity as kind of a legacy product because we moved heavily from TeamCity to Jenkins. And the Jenkins run on top of Kubernetes. And so we have the build, the deployment, it's actually based on the service. I mean, we have a legacy services that runs based on Nomad, but we do have also most of the services are moving heavily toward Docker and Kubernetes. So we use Helm, and we use Helm to deploy the services in Kubernetes directly to the cluster. And after the build, we archive, also based on the service, we archive our stuff to NuGet, Baget, Artifactory, Harbor as a Docker registry, and we have some also proprietary solutions for archiving. And at the end, we scan our product based on SonarQube, check marks, which is the static code analysis for security, and we use Ment, is known as formerly white source. We use it for dependency management for our open source. And finally, at the end, we provide notification to the developers in Slack and also expose ourselves to reports in Kibana using Elastic. And this is the quiet structure of the CI for each service. And if we look a little bit above, so the developer is actually pushes code to the GitLab and the CI process is running. And at the end, the developer is able to decide when to deploy to production. So we are actually running continuous delivery, not continuous deployment. We're moving to this process. And that means that the developer is actually click the button to deploy to production, and the developer is the one who is running the deployment to production. And we have two ways that we are deploying to production. One of them, we have a Jenkins deployment pipeline, and the other one, it's an in-house tool for deployment. And the deployment in the in-house tool, it's quite simple. We choose the service, the version, the data center, affinity, or how many instances do we run, and we are validating that this version passed security tests, security scans, and integration tests, and finally click the button and deploy to production. And the other way that we are deploying to production is using a Jenkins pipeline. And again, we are moving heavily to the Jenkins, to the pipeline, and that means that all you have to do is just pick your service, choose the version, the cluster, and the data center. And finally, you will get a pipeline for the deployment. That means that we run a sanity on production before the deployment. After this, we run some application tests on the specific service that you deploy to production. And finally, we make the deployment to production and run the same sanity like we ran at the beginning. It's something that takes something around approximately 5 minutes. And if this prod sanity fails, we automatically roll back to the previous version. And in that way, we can ensure that the developer can feel confident that we are not breaking the basic sanity in production. That means that we are keeping the production stable as much as we can. So as I mentioned previously, our developers own the entire process from IDE to production. That means that we are not providing any deployment solutions. We have no deployment team. The DevOps are not the one who deploys to production. We're just enabling the process. We're just enabling the tools. And the developer is the one who is accountable for the process and responsible to deploy to production. A little bit about our architecture. So we are running a microservices environment. We have 300 microservices. I will move to this place, feel more comfortable. So we have 300 microservices. I always give the example of the hamburger as a monolith, and each part of it, it's a microservice. So we moved from monolith to microservice something around 5 years ago, and it was quite challenging, but the main idea is that each service has its own identity, its own life cycle, and each service exposes himself to the other services based on the needs and based on the role of the service. And each service has actually its own code repository or repositories, its own policy, the life cycle, the deployment rules, and obviously whatever it needs in the infrastructure, whatever it's a Docker or Kubernetes cluster or VM that is needed for the service. How many of you, by the way, are dealing with microservices? Okay, cool. Something around 20%. So you probably know that supporting developers, I mean, most of us are DevOps engineers, and supporting developers in microservices environment might be a little bit headache, and I will explain exactly how do we make the support. So, first of all, we have a lot of roles and responsibilities in the support. So we are supporting, first of all, pipelines. This is the basic CI/CD stuff that we need to support developers. So we are maintaining a we are maintaining in GitLab Jenkins shared libraries based on any technology. I mean, we have .NET pipelines, Java pipelines, Scala pipelines, NPM, and so on. We are also supporting the infrastructure. I mean, we should provide support in the infrastructure about how to use Git, how to use Jenkins, the uptime of the Jenkins platform or the TeamCity, and of course, anything that related to binaries repository, we need to support the developers. We are also providing support to the third-party code scan tools like Checkmarks, SonarQube, any static code analysis. We're using also Black Duck and Mend for security scans. So we provide the support to the developers. And finally, we need to provide support in the deployment and troubleshooting issues like error analysis, runtime, access to logs. I mean, developers mostly need access to logs, and they have no permission to log in directly to production, so we need to provide the support. And obviously, the basic runtimes of the pods on their services. So first of all, we have no ticketing system. I mean, normally, especially in the IT world, most of the users prefer to use any ticketing system. So if someone asks a question, they ask him to open a ticket, and he needs to wait for a solution. So we have no ticketing system. We have a public channel in Slack. How many of you are using Slack? Okay, so we have a public channel in Slack, and that means that this public channel it's being monitored by on-call from our team. And if you have any question, you should post your stuff in the Slack, and the on-call will be able to answer. So in this way, we have a lot of benefits. So first of all, it's not annoying to open a ticket and wait for it. And then everyone are able to see the status in the Slack. So first of all, everyone can see the status for each issue. If you see that there are a lot of questions about Artifactory, which is down, for example, you know that probably someone is dealing with it, and you can see the status with all of the developers. We can easily communicate to the developers messages ad hoc by using a channel or here annotation in Slack. That means that everyone will get the alert. And it's also create an interactive mode where developers can help other developers. Sometimes as an on-call, if a developer asks a question, another developer answers his question, and he gets the answers, and we have nothing to deal with. So it's very interactive, and it's very easy to develop special bot that helps the support process. For example, if you tag the team leader, then their bot will redirect you directly to the on-call, or if you send messages after the working hours, you will get a specific message from the bot. Or if you send a job and we identify that you send a link to something, we can suggest things that you might do for troubleshooting and solve your issue. So the main common cases that we have in support, and probably as a DevOps engineer, you're dealing also with supporting developers. So the main processes and the common cases that we have to deal with is, first of all, bug in the production, bug in the processes or the tools. I mean, we write huge pipelines. There are a lot of processes, there are a lot of tools, a lot of infrastructure configuration, and we may provide some bugs with it. So we need to support the bugs in front of the developer, which is obvious. We also need to support junior developers. Sometimes we have a junior developers which are less experienced, so they need more guidelines about how to read logs, how to identify the issues within the logs, or something like this. So this is quite common. We have lazy developers. Sometimes developers, as you probably, I'm pretty sure that most of you are familiar with it, but a lot of developers are quite lazy to open the logs, quite lazy to search the issue in the log, or like it's written, RTFM, read the fucking manual. So in general, sometimes we can say to the developer, okay, what is the problem? Scroll down, see the error. There you go. So sometimes we need also to spend time to support developers in this issue. And also, sometimes we need to solve and support complicated issues. And it's indeed the developers need our CI/CD expertise in order to help them to understand the issue. So when we have too much support, we have no control. I mean, if we have to deal with too many developers that need support from us as a team, we have no time to add new technologies, we have no time to enrich our pipelines, we have no time to enrich our tools, so we have no control about it, and obviously we cannot commit to our sprint task as a team, as a DevOps team, and finally, we are endangerous and disturb our developers' streamline. And this is the reason we choose to integrate our solution, our CI/CD pipelines, to the ChatGPT. And I will talk about it right now. And this is the solution actually that helped us to remove a lot of noise in the support channels, in the support in front of the developers. So our integration to ChatGPT started as a SAP worldwide hackathon about a year ago, approximately. So we took the first place worldwide in SAP, and we implemented it in our pipelines, and we have also a patent pending on this solution, and I will introduce it now. So if we look from left to right, we have the Jenkins build that runs the CI/CD pipeline. And when I say pipeline, I'm not necessarily deal with build, but also with deployment or any job that runs on the pipeline itself. So as soon as something fails in the Jenkins, we are sending the error to an engine that runs on Python, on Kubernetes, and the error makes its decision whether it needs to be sent to ChatGPT or not. And if it does, we send the error to ChatGPT, get the result, and send it directly using Slack to the developer. So that means that I will try to drill down for each part of it. And I will also talk about the obstacle, because the solution, to be honest, is not that perfect, but I will drill down and explain exactly what are the obstacles and what are the upcoming things that we will need to deal with it. So first of all, the application, it's a Python server that runs on Kubernetes, and this Python server is able to send post request to ChatGPT and get the results and send it to the developer. The Jenkins pipeline. I mean, most of us are deal with Jenkins. Most of us are mainly deal with CI, and Jenkins is the most popular CI/CD tool. So when we have a Jenkins pipeline, we have the shared library, and we are trying to identify the error from the console log. I mean, you probably know that read stuff from the console log, it's very easy when you open the console log, scroll down and find the error. But as a human, we know how to identify what is an error and what is a noise. I mean, you probably know that exception, for example, in Java, you have the caused by, but we know exactly which one is the relevant. But the main obstacle is to identify it programmatically. So This is one of the main challenges, and I will elaborate it. But in general, the pipeline needs decide whether this error needs to be sent to ChatGPT, and again, send the error to the developer. So this is exactly the solution. And the developer, as soon as something breaks, get a message in Slack. If you're familiar with Slack, you're probably familiar with the UI of Slack. So this is an example by the hackathon demo that we try to break build on Java project, on Maven project, with the missing semicolon, okay? So obviously the build will be broken, and so the build is broken, we send it to ChatGPT, and ChatGPT analyze the issue and send it to the developer and explain exactly that missing semicolon in Java class, blah, 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 and the developer should get a proper solution and understand exactly, instead of ask the developers or ask the DevOps team, why my build is broken. Okay, you got it. You have it on your own channel. You can see the results and you can fix it. And the most interesting part that each time that I will run the job, the solution will be a little bit different, because ChatGPT is creating the error, collecting the stuff. But again, if I run this error, I guess in 6 months from now on, I will be able to get more accurate result, and because ChatGPT is also learning, and this is the thing that we are quite based on it. But as I mentioned previously, and to be honest, the solution, it's not always perfect. It does bring a lot of benefits, but it's not always perfect. And if you want to integrate ChatGPT within your CI/CD pipeline, I'm pretty sure that you will have some obstacles and you will have some challenges that you will have to deal with. So first of all, as I mentioned previously, one of the challenges is identify the error from the huge console log. Sometimes the error may find itself somewhere between the logs, and it's very easy for us as an experienced DevOps to identify the log and understand exactly why the build is broken. However, programmatically, it might be a little bit challenging. So we're trying to solve this issue by marking within the pipeline, marking some special errors, special messages, and try to find it within the console. But we still have a lot of work to do in this area. We have to make sure we are not sending a sensitive information or data to the ChatGPT. I mean, we're using an SAP appliance and we're not sending directly to the ChatGPT. However, we don't want to send sensitive data or, I don't know, for example, customers' data that are part of the build. We don't want to send it directly to the ChatGPT. And we are trying to analyze it and understand exactly what is the problem and what should be sent and what should be blocked. We need to make sure we are collecting the exact error, because sometimes, I don't know if but how many of you are working with Jenkins? Okay, about 50%. You probably know that almost any error in Jenkins starts with org Adson something, right? So in that way, it doesn't make sense to send it. We get no data, we get no benefit of sending this data. So we need to collect the exact error to the server. And we have a lot of tools, a lot of internal tools that are part of our CI/CD, and sometimes those tools get fails and fail the pipeline. And if I have a tool that I call it ABC, probably ChatGPT won't help me to solve the issue, because ChatGPT is not familiar with my tools. So sometimes we need to identify whether if a tool, an internal tool or internal process is broken, we want to send the exact error to the ChatGPT. And if it's not relevant to ChatGPT, we want to send it to the developer a specific alternative solution, which is quite hard-coded in our area. We need to monitor the effectiveness of the solution. I mean, the main goal of implementing a ChatGPT is to reduce the support request from our team. and leave us to develop some more interesting stuff. So we need to measure whether if it's working or not. And for now, it does work. We have less requests in the support, and we get also a copy of each failure for a specific channel in Slack. So sometimes when a developer asks us about a broken build, we can see the error that the developer got, and we say, okay, what is not clear in this error? You got it directly to your Slack channel, and it helps us exactly to set the developer to read about and learn about the solution from the ChatGPT. So in general, as a DevOps engineer, we're not trying to do a DevOps stuff. We're trying to enable a DevOps processes and help the developers to be more focused in the development in one hand, but also take the ownership and the accountability about the processes themselves. So we're trying to enable the DevOps culture, and this was the solution of the ChatGPT. So first of all, thank you all for joining the session. And if you have any questions, I'm here. Yeah.
How did you, like, what strategies did you use to identify errors in the logs? Like did you just grab for error or something like that, or something more sophisticated? Because this seems like the biggest challenge.
Yeah, indeed. This is the biggest challenge. And again, we're still working on it to improve it and enhance it. However, we're trying to, for example, if we have the checkmark scan issue, and we're trying to wrap the pipeline. I mean, if I'm sending a command of scanning in checkmarks, we're trying to wrap the pipeline with try and catch, and we're trying to append to the catch error a specific message. So as a start, we're trying to search for these specific messages. And in case this specific messages is there, that means that probably this is a checkmarks issue, and probably this line is the one that I need to analyze and set it to the ChatGPT. This is just an example, but normally we're trying to wrap every command in try and catch, and in the catch we try to append a specific character that we will be able to identify during the log analysis. Yeah. What do you mean? We use what?
Your own model, like not using ChatGPT, but host your own model so you can use sensitive data because it stays in your premises.
Yeah, we do, but we got an instruction not to send it anyway. I mean, finally, at the end, it runs on the solution. It's not running within ChatGPT. I mean, it's run on Azure account that belongs to SAP. However, in any end, we're sending the data to behind the scene, it sends the data to the ChatGPT and get the results. I mean, we're not hosting the ChatGPT data within SAP. So we are having the idea of having an internal instance. It's just manage the connection and the logins and the permissions to use it. However, the data is being sent anyway to outside the internet. It's quite challenging, but for example, we're trying to see that if there is a kind of a regular expression that if we get something around password, for example, I don't know, if a developer forget a password as a backdoor in his code, and we're trying to identify if it's a password, so we're blocking the sending to ChatGPT. But again, when you develop such a solution, you have to, I mean, in our case, before we release it to the developers, it ran something around 3 months and send the errors only to us, and we try to accurate it and try to understand it. But it's indeed challenging, and to be honest, you can find yourself also sometimes sent irrelevant data to the ChatGPT. It's not perfect. Yeah. Yeah, so as I mentioned previously, we're sending, as a developer, if you get a broken build, you will get the error. But also we have a public channel internally in our team that we are sending the error. And once in a while, we're moving on all errors and try to understand if it's reasonable. And if it's not reasonable, sometimes we are providing a fix to the service. But there is no automatic way that we can identify it. We have to look at it as a human.
Does it increase your cost? Like doing every call to ChatGPT for every failure, so you have to pay for that, right?
I mean, I work for SAP, it's 110,000 employees. So when we got login to ChatGPT, we don't care about the price. Someone else is dealing with it. I'm pretty sure that if I was part of a 20-employee startup, I had to deal with it. But you know, when you work in a huge company, you don't care about instances on AWS, or we find ourselves using an instances that runs for ages and we didn't know about it. So this is quite similar in the ChatGPT. Yeah.
In terms of error analysis using ChatGPT, very often I run into the problems that the context is missing. So that it can respond to the error and give me some solution, whatever, but it doesn't know much about my CI/CD pipeline. How have you as well this challenge, or do you enrich your error messages with context about your system, about the environment?
Yeah. Yeah, so again, if it's an internal tool, the ChatGPT won't be able to provide me solution because he have no idea about my internal tool. We are trying to block it. So in case we have a try-catch within an internal tool command, we're not sending it to ChatGPT, and we send the developer kind of an hard-coded error, so we will be able to analyze it. For sure, in most cases, ChatGPT will be valuable in a compilation error or unit test error. So normally when compilation error, it's quite generic and you will be able to get the proper solution. But yeah, in case it's internal process, we're not sending it to ChatGPT. And we have a lot of try-catch within the pipeline in order to identify exactly the error. But again, not always we're able to catch the exact message, but I can ensure that if we are looking about, I don't know, 8 months ago till now, so 8 months ago, probably 60 or 70% was irrelevant, and today we are standing around 20%, and we are trying to make it lower. Yeah.
Developers adapt the pipelines or build their own, or is it all managed by you?
Yeah, that's a good question. The question was, are the developers managing their own pipelines? So the answer is no. We are managing the pipelines. We have a shared library in Jenkins, and they have to use this shared library. And the reason, I mean, as a developer, if you want to enrich or if you want to contribute, you can open a merge request in GitLab, and we will decide if we get it or not, if it helps or not. And the reason we are doing it, because we found we used to have, the developer used to have the full permission to manage the CI/CD pipelines. And we discovered that, I mean, we have 300 microservices. We discovered that there were a lot of services that, for example, the developer marked the security scans because it didn't work in that time and he had to make a progress and he forgot to unmark it. And we found ourselves that services are running in production without security scans, and we are not able to allow it. So we decided that we will manage it, and we will have the permission to manage everything. And if you, as a developer, want to enrich something that's relevant to you, be my guest, open a merge request, we will review it, and we will decide if it's good or make a benefit or not. But if you provide the full permissions to the developers to manage the pipelines, you can find yourself without very critical steps like security scans, and developers doesn't like scans. They like build, they like a product. So this is the reason we're trying to hold the permissions in our case. It's not ideal, it doesn't sound good, I'm pretty sure, but this is the only way we can ensure that scans and security will be part of the pipelines. Yeah. Slack, it's plugin. I mean, you can install plugin on Jenkins and write a single command to send it to Slack. It's pretty simple. ChatGPT, it's not a plugin. I mean, we're just having an instance that knows how to get a post and get request. This is the internal Python server that we are running, and we'll simply send the result to this engine. So it has nothing to do with Jenkins plugin. It's just sending an HTTP request. Yeah. Yeah, okay. How do we recognize the Slack channel? I didn't talk about it, but we're managing microservices, and each microservice, it's actually part of a database. That means we have a database of each service, and each service we have the name, the Git repository, the owner, the team, the type of the service. That way we know in this way we know automatically that this service needs to run a .NET pipeline or a Scala pipeline, and also we have the Slack channel of the service. So finally, this database is being exposed in JSON. So as soon as we start the CI process, we are reading the JSON data, and we know exactly that this build should do that. This build should sync from this repository, and obviously this build should send to the relevant Slack channel. Yeah. Yeah, yeah. Yeah, so the question was did we consider using a Jenkins plugin, right? So there is a Jenkins plugin that's called Log Analysis, but the last update of this plugin was something around 5 years ago. So I'm pretty sure that it contains at least, I'm not sure if it's working or not. I guess it will not work with the new core because 5 years, it's a long time. And if it does, I'm pretty sure that at least it uses the old log4j 1 point something, and we don't want it. But anyway, it's not that ideal. We read about this plugin. We didn't install it because it probably will fail something else. But I'm pretty sure I read about it that it's quite challenging. I think it's open for adoption for years, and no one actually took the ownership of it. I wish we had a plugin that knows exactly what to analyze, but I guess it's not necessarily by accident that we don't have such plugin, because this is something that no one wants to touch it, I guess, because it's challenging.
What were your main reasons to move away from TeamCity?
Yeah, so TeamCity, it's a commercial tool, great UI, by the way. I mean, 50% of you are using Jenkins. It's free, it's lightweight, it's open source, and very flexible. But the UI of Jenkins, it's quite sucks, right? TeamCity has a great UI, but it's less flexible than Jenkins. In order to develop specific steps, you have to write it in Kotlin. If you write it in Kotlin, you have to get the expertise for that. It's as a DevOps team leader, it's much more easier for me to recruit employees that knows how to deal with Jenkins and Groovy, unlike Kotlin. And people want to touch the most popular technologies. So this is the reason we move. By the way, TeamCity is also expensive. I mean, we pay for our 200 people group, we're paying something around $20,000 per year for a license, and Jenkins is free. Yeah, yeah, for sure. But this is not the main idea. We don't care, but when we moved from TeamCity to Jenkins, we want to have the more flexible solutions. Yeah.
Do you know how big is your DevOps team to scale and manage this DevOps?
Yeah, okay. So how big is our DevOps team? So we have many DevOps teams. So we have something around 4 DevOps teams. And my team, it's deal with each team in my group. It's responsible for other topic. So we have teams that are responsible for infrastructure, like the AWS, the Azure, the Kubernetes cluster, and so on. My team is responsible for CI/CD. So we are developing and enriching the pipelines of the CI/CD and the deployment processes. So my team, it's actually, we are 5 people. We used to be 9, but it's hard times. And right now it's me and another 4, and we're working on recruit more people to the team. Yeah. It really depends on the developers. Some of the developers prefer to use the Blue Ocean. Blue Ocean looks better, for sure, but I think I personally prefer the old classic UI. I mean, it has a lot of stuff, a lot of bugs, a lot of performance issues for the Blue Ocean, so I'm using the classic. But you can decide. Yeah. What do you mean by getting the error again and again? For example, if there is like retries. Actually, we didn't deal with it because we catch something, whatever it's the first one or the last one, we don't care if it's the same error. But it's a good point, by the way. I didn't think about it. The Slack channels are there already. I mean, each team.
300 microservices, so does it mean that there is one per each?
No, as a team, I mean, we have something around 20 or 30 teams. Each team holds multiple services. There are services which are huge, and there are services which are barely changed. Okay, guys, if you have any other questions, I'm here. Feel free to approach, and thank you for joining my session, and have a great conference, and thank you.